it's really important to understand what the mean variance frontier actually means. A lot of this course we explore in great detail how to interpret the mean variance frontier. Let's construct an example. Suppose we've got 5 years of data, say from January 1995 through December 1999. And we've got perhaps 5 asset classes. We calculate the average returns, the variances, and the covariances, and construct a mean variance frontier. The first thing that we need to understand is what it means to lie on the frontier. Suppose we looked at a portfolio manager that invested in the same 5 assets over the same time period, 95 through 99. That portfolio manager, suppose that manager's performance was below the efficient frontier that we drew. What does that mean? Well, the first thing that's really important to realize is that the efficient frontier is drawn based upon the knowledge of all of the return observations. Given what we know, given that we know all of the returns, what are the set of portfolios that have the maximum expected return for a level of variance? So, indeed, it doesn't seem fair to evaluate a manager who's setting out, forming a portfolio, deciding upon weights in the 5 assets in January 1995. To compare that manager to an algorithm that determines what the optimal weights are based upon full knowledge of the future, it's not clear that's fair. Indeed, maybe the best way to view it is that the mean variance frontier that we draw based upon historical data is like a manager that has perfect foresight, a manager with an oracle. And sometimes I call this the oracle frontier. So if you knew what the returns were going to be, this is the best that you could do. For each level of volatility, here's the maximum expected return, and here are the weights that deliver the maximum expected return. So it's very important to realize, using historical data, that the mean variance frontier is like a hindsight frontier. It represents the best that could be achieved given knowledge of all the returns. Now, a question always arises. Is it possible for a manager to achieve performance in the example that I just gave on the other side of the frontier? So instead of underperforming the frontier, is it possible that a manager could perform better than the frontier? The usual response is that it is mathematically impossible to do better than what the optimizer tells us is optimal. It turns out that that's not correct. And we really need to think hard about what the mean variance frontier actually represents. For some level of volatility, we maximize the expected return. And the program delivers a set of weights that do that. And to keep the example highly simplified, suppose that those weights are 20% in each asset class with 5 assets. This is like equal weights. Now, if we were actually going to construct this portfolio, this oracle portfolio, for some level of volatility, the program tells me 20% in each asset class, then what I need to do is to make sure that each month over the 5-year sample, I have my portfolio weights exactly equal to 20%. What does that mean? Well, that means that really what we're considering is a particular portfolio strategy that I refer to as a fixed weight strategy. that weights must be the same over the 60 monthly observations. And if we really think about what's going on here, after the first month, if it's the case that asset 1 increases in value and asset 5 decreases in value, then in order to achieve the 20% weight, asset 1, I need to sell some of it, and asset 5, I need to buy some of it. So the assets that do well, I'm going to be partially liquidating, and the assets that do poorly, I'll be putting more funds to them. What's this? It's kind of like a contrarian investment strategy. You sell the winners, buy the losers. It's not the traditional contrarian strategy that we are used to thinking of. It's more a mechanical strategy. The program tells us that we have to have equal weights. So the frontier that we consider optimal, the usual frontier that we're dealing with, is a frontier that only considers fixed weights. The weights must be equal every single period. Is it possible that a portfolio manager can have a portfolio performance over the same 5 years without knowledge of what actually happened in terms of the asset returns, to have a performance on the other side of the frontier? The answer is yes. However, in order to achieve that, the portfolio manager's weights cannot be fixed. The efficient frontier of fixed weight strategies is the best that you can do mathematically for all fixed weight strategies. But as soon as you allow the manager to actively change the weights through time, then that is the same thing as introducing new assets into the optimization. It means that it is feasible to have performance on the other side of the frontier. So active strategies, and this course is mainly focused on active strategies, have the ability to deliver performance above and beyond what is expected according to the narrow set of fixed weight strategies that the usual mean variance frontier details.